Oh, hi there, everybody, and thanks so much for showing up for your math learning. It's me, your humble math servant, Mr. Jennings, and today we are looking at finally, like our main topic for this unit, which is factoring these higher order polynomials. We've been spending a couple years, grade 10 and grade 11, getting very skilled at factoring quadratics. And those skills never grow old, okay? We're not abandoning those skills. In fact, that's still the backbone to what we're doing. But we need these extra tools, factor theorem and polynomial long division notably, in order to conquer these higher order polynomials. The slides that we're going to look at today, I just realized, they're going to reference something called synthetic division of polynomials, which I'm not going to cover. It's something that's outside of the curriculum, but it's just a different way to do your long division with a little less writing and a lot more restrictions. So let's keep it simple. Let's just use our polynomial long division. If synthetic division is something you want to investigate, I'm here to support you, and I can help you with that. Let's go. We want to be able to do this today. You want to still be able to state the factor theorem. That was Friday's lesson. And use the factor theorem to find factors of a polynomial. Once you get that first factor of a cubic and you divide it out, you'll end up with a quadratic that you can factor quadratically. If you really love polynomial long division, you can long divide your quadratics and factor them. It all works, okay? So we're going to have even more tools than we've had before to do this. And we want to fully factor polynomials. That's our goal. Get things into their fully factored form, because as we saw when we were sketching, when you can put polynomials in their fully factored form, that's when you can sketch their intercepts, you know, the nature of those roots, and you can create some really good sketches that way. So that tells you what the function is doing at different points. Let's go. So if we wanted to divide this polynomial here, which is a quadratic by x minus 1, go ahead and long divide that and see what it's like. Okay? I'll pause the video and you go and do it. Starting the video again. All right, so let's see. What remainder did people get? 12. Did anyone find it went evenly? Oh, wait, I shouldn't do that because then I'm trapping you into the wrong answer. The remainder is indeed 12. Okay, so check your work against mine. If we're going to divide this into this, we're going to get this remainder 12. So I do multiply by x and I subtract that thing, so we get x squared minus x. Minus x gives you 5x plus x is 6x. Bring down this 6. Multiply by plus 6 to knock away this 6x. And we get minus 6. That's where you might have thought this went evenly, but it doesn't. It doesn't go evenly. Now, how could we have used remainder theorem to predict that we would get this remainder? Well, oh yeah, okay. Go ahead.
You put a positive 1 into the x's.
Mm-hmm.
Oh, that's actually random. I forgot about that.
Putting 1 into a function is one of those like really fun things you can do because it's easy. You just add the coefficients together because 1 squared is the same thing as 1 cubed is the same thing as 1 all the way through. Doesn't matter the power. So that's something that we're going to notice today. When you're inputting 1 into a function, it's really smooth, and you just add the coefficients. Yeah, and Mateus, you remembered from remainder theorem that if you're dividing by x minus b, then you can just do f at b, and that will give you the remainder there. If the remainder is 0, that would tell you that x minus b is indeed a factor of the polynomial you're looking at. So well remembered. That's good. So then we talk about synthetic division and why we don't want to use it all the time, and we're going to skip that. But we have here factoring polynomials. Okay, we can utilize this factor theorem to find the factors of polynomials. So this is the real trick when we have a quartic or a cubic, is finding that first factor we can take out is often going to be the trickiest thing. So then once we do that, we can use a division strategy. We're just going to long divide. Okay, so we're going to long divide that x minus b in once we find a b that gives us f at b equals 0. Okay, so when you're finding factors of a polynomial, the possible factors are factors of the constant term. That is to say, if I have some polynomial, which is a function of x, which is equal to x to the n times, well, say ax to the n plus bx to the n minus 1 dot 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 z is our constant term. Okay? You look at factors of your constant term. So breaking that number down into its prime factors and looking at all of them, one of those is likely to be one of the factors of your polynomial. It's just naturally the way that's going to fall out. If we have a leading coefficient, on the other hand, in that case, we would be looking for factors of z divided by factors of a. Okay? And that's going to give us our possible factors of those more challenging situations. Okay? So we have, that's interesting, they say two options. We have one, but again, if you want to learn synthetic division, I'll learn alongside you. I know how to long divide. I don't know synthetic division. Synthetic division has more limits, but it's a little faster. Okay. All right. So let's talk about this one. If we have a leading coefficient 3 and a constant term 2, what are some of the possible factors of this polynomial? How would we find some of them? 1. Someone said 1. Good. It's possible factors. So what are the factors of 2?
1 and 2.
Yeah, so we have 1, 2. Anything else? Does it divide evenly by -1? Yeah, it does, sure. So we can divide by the negative versions as well. Okay, so those are some of our possible factors we might want to consider. And then if we had factors of 3, so the factors of 3, we just have 1, 3, -1, and -3. These are uninteresting numbers because they're prime, so they only have themselves and 1. But if we're looking for possible factors, we want to look at the factors of b divided by the factors of a. So what are now our possibilities? We might be something like 1, 2, -1, -2, 1/3, -1/3, 2/3, and -2/3 might be the different factors that might emerge from this polynomial. Okay? So if we wanted to know, is any of those giving us a root? Like, is any of those actually a factor of this polynomial? How would we find that?
The factor theorem.
Yeah, you're going to apply factor theorem. So we're going to input. So which one's the easiest one to test here? 1. Yeah, let's go. So if we look at p at 1, you're just going to go through and add up the coefficients. 3 plus 2 minus 7 plus 2. What does that tell you about this one? Anyone happen to be able to do 3 plus 2 minus 7 plus 2 without a calculator?
0.
Yeah, it's 0. So since p at 1 equals 0, what does that tell us about something? Therefore, yeah, 1 is a factor. So, sorry, did you say x minus 1 is the factor? There, yeah, so therefore, x minus 1 is a factor. So now, we can go ahead and fully factor this, given that we know x minus 1 is a factor. Probably, I would expect some of these other ones are also factors. Look, you got that leading number 3, so no wonder some of your factors are going to be divided by 3, am I right? Should we test those? Nah, let's just long divide and factor it. They're going to come out. So find the easiest one to find, divide it out, and you're going to find the harder ones to find. Let's go. So we're going to go ahead and divide this by x minus 1. Okay. We're going to divide that into 3x cubed plus 2x squared minus 7x plus 2. Go ahead and work it independently. I'll work it before your very eyes, and then compare your work. Okay? So let's go. Going to multiply by. And we're very happy to see that 0 at the end of the long division, because that means we were indeed right. It's a factor because there's no remainder, meaning it's dividing in evenly, and we get this quadratic here that we then need to factor. Okay, so we have f of x now. Note, this is all rough work. Notice how I separate my rough work on one side of my page and the flow of my solution. So over here I have the flow of my solution. F of x is therefore equal to x minus 1 multiplied by 3x squared plus 5x minus 2. Okay? And then we go ahead and factor this. Again, if you need rough work, do that separately. So maybe I do that up here. I'm just going to go up here and factor 3x squared. I happen to know I need to win this x game where I multiply to 3 times minus 2, and I add to 5. And the numbers that multiply to negative 6 and add to 5 are 6 and minus 1. So I'm going to decompose that middle term. Okay, and then I factor out a 3x here by grouping, and I have x plus 2. And then I factor out a minus 1, and I have x plus 2. So then I know that this quadratic factors into 3x minus 1 times x plus 2. And that was all rough work, because I want to just now write f of x is equal to x minus 1 times 3x minus 1 x plus 2, okay? And there you have it. So it's fully factored. Now I've got it into 3 binomials. They're all linear. Those don't factor, so we're done. So now let's compare to the factors that we predicted we might have up above, and let's see which ones we did find, okay? So we had, this one is x equals 1 is one of our zeros. X equals minus 2 is another one of our zeros, and here x equals 1/3 is another 0. Okay? And if you go up here, you'll notice, yeah, they were all there. They were all predicted to be possible, but oh wait, no, not that one, this one, minus 2. Okay, there. So they were there, but they're harder to divide out. Just work with the easiest one first. Questions about how to fully factor that cubic, or is that pretty clear? How did x to the 2 turn into something? Where? Okay. Maybe I'll circle back around to that table in a minute and we'll talk about it. Okay. So what are our possible factors here where we have a leading coefficient 1 and this number minus 18 at the end? Oh, wait. That's where I'm going. No, we got another page. What are the factors of minus 18?
9 and -9.
Yeah, so we've got 9, -9, 18, and -18, don't forget.
Then 2 goes along with 9.
2, -2.
-3, +3, 6, -6. Oh, we already got our cubes.
Oh yeah, I already did 2s, yeah, right. 6. Are we missing any?
1.
1 and -1. Okay, so which one do you want to test first and see if it works? Okay, cool. And we're going to fully factor it, so we want to find the one that works. So does 1 work? When you put 1 in here, does it work? Someone tell me no, absolutely not.
No, absolutely not.
1 doesn't work. How can you tell that very quickly? If we look at f at 1, we just add up the coefficients. The coefficients would add to a really negative number. 1 plus 3 minus, minus, minus. And it's all the big ones. So no, it doesn't work. So what should we test next? Let's test minus 1. Minus 1's pretty easy to test. Okay? And let's take a look at how we test minus 1. So f at minus 1 equals, I'll do it really formally, minus 1 to the 4. What's that going to be? That's 1 plus 3 to the times minus 1 to the 3. What's that going to be? That's -3, right. So basically, you're going to add your coefficients together, but do plus minus, plus minus, plus minus. All right, so it's a little more thinking. Maybe write down some steps and don't make an error. You want to find this factor if it exists because it's easy to divide out. Okay, and then minus 7 times negative 1 squared. And then minus 27 times negative 1. What's that going to be? That's going to be plus 27. Okay, so we got minus 3, minus 7, because negative 1 squared is 1, and we're minus 7 times 1, plus 27, minus 18. What's that equal? Aren't you glad we tested that one before 2? 2, you got to do things like 2 to the 4 is 16, and 2 to the 3 is 8, and you got to like memorize all that for the no calculator test. Yeah, good. So this one works. So now we know what to long divide out first. So let's go for it. Okay, so x plus 1 is a factor of x to the 4 plus 3x cubed minus 7x squared minus 27x minus 18. Let's go. We're going to multiply by x cubed here. So that means we're going to be taking away x to the 4 plus x cubed. Okay, and so that gives us 2x cubed when we do minus minus, and then we drop down this minus 7x squared. We need to multiply by 2x squared to get the next thing, so that's going to be minus 2x cubed minus 2x squared. Sorry, plus, but we're going to subtract. So this is, of course, 0. This gives us minus 9x squared minus 27x. So we're going to be minus 9x there. Gives us minus 9x squared. To knock that one out, minus 9x. And we are, of course, subtracting. So minus 27x minus minus 9x is actually 18x, but it's negative. Good thing it is, because when we drop down that minus 18, notice we just now need in here minus 18, and then we knock that down, and then we have minus 18x minus 18. You find your final remainder. I could have done it with my own face, but we get this happy 0. So we're pleased. Okay, now we can carry that on. We say f of x equals x plus 1 multiplied by x cubed plus 2x squared minus 9x minus 18. And now, how do we factor this business? Boom! That's beautiful. We can group this one. This one can factor by grouping. Let's go. I love it. So this one you might do separately, or you might do right here. Let's do it right here. You can keep these in the flow of your solution if it's beautiful like this. So we have f of x is equal to, how did you notice you could do grouping here, Connor?
Well, I saw the negative 9, negative 18, and I like that, so I kept it like that. And then we can factor it x squared out of x to the cube and 2x squared.
All right. So Connor noticed that there's the same pattern in the coefficients, right? 1, 2, negative 9, negative 18. They're separated by the same ratio, and that often suggests we can factor this by grouping. So great move. And then when we do that, we get f of x is equal to x plus 1 multiplied by x plus 2. There's one of the other factors that we said we might find. Multiplied by x squared minus 9. Very good. Who wants to do the coup de grace? The final finishing move. It's like your enemy is at his health bar is totally depleted, and someone says, finish him.
You just rearrange it in order.
Is no one else having as much fun as I am?
Difference of squares.
Yeah, it's the difference of squares. Slam dunk. Booyah. This is great news. We just factored a quartic together, everybody. Factoring quartics used to be really hard, but now we do it easily. This factors as a difference of squares. And then you've got like both of your varieties of 3, your negative variety of 2, your negative variety of 1. And if we looked at it, we had negative variety of 1, negative variety of 2, negative variety of 3, positive variety of 3. There were your factors, and they were all predictable just by looking at the factors of minus 18. Okay, let's keep going. That's how you factor a cubic. Boom. All right, so this one here, if you were given this type of problem, again, it's very similar, so I'll do it. I'll show a solution later. But if we were told that the volume of a pool is equal to this cubic function, and you wanted to find the dimensions of the pool in terms of binomials of x, you would factor it. Find out what they are. Okay, we'll move on, but I will show you a solution in just a moment. And then, so then it's like, oh, fully factor this one. Another example. I'm kind of like over that. I want to do the special cases. So here, how do we factor this one? X to the 4, so we are cubic. We are doing, sorry, quartic, sorry. So we're doing this dance. We have this end behavior. But how does this one factor? Should I test and see what factors it has? Anyone see a shortcut? It's a trinomial. Looks familiar. Seen this? No? No one knows? Okay, this is what you can do. You got it?
You like substitute like a 0x cubed and
0x cubed. You could write it as equal like x to the 4 plus 0x cubed. Yeah, you could do that. But you're going to like this other way that you can do it even better. Okay? This is what we call quadratic in terms of x squared. Notice that this one is just a square of that one. So here is a trick that you can do. You can say, let x squared equal v. All right? And so now we have f of x equals v squared minus 2v minus 15. And that's just a quadratic, right? Okay, so we can just factor that. So that's equal to v minus 5 times v plus 3. Okay, make sense? Now, let's put that back in because we want to show it as a fully factored x squared. So this is equal to x squared minus 5 times x squared plus 3. All right, and that's f of x. And then what should we do after we do a whole bunch of algebraic jumping through hoops and doing a bunch of abstract stuff that we don't really fully understand? I don't really fully understand what just happened. I'm just confident that my algebra is good. But what should I do? Someone tell me to check my work because I shouldn't trust myself.
Check your work. You shouldn't trust yourself.
Good, good. So I'm going to do this. X squared times x squared is indeed x to the 4. X squared times 3 is 3x squared minus 5x squared. 3x squared minus 5x squared is indeed negative 2x squared. And negative 5 times 3 is indeed minus 15. I just got a mental math workout. And I get a pat myself on the back moment because I did the problem 2 different ways and found the same answer. So I'm very pleased with myself. So you should get those opportunities too to be this happy with yourself. So check your work. Okay, that's how you fully factor that one. And then this one, Connor, how can we factor this one?
Same ratio, right? It's by grouping.
This one's by grouping as well. So you don't have to long divide if you can spot a different strategy. This one factors by grouping. So we have x plus 3 times x squared. There, that's that group. And then this group has plus 2 times x plus 3. Because we have that same ratio in this coefficient to that coefficient as this coefficient to that coefficient, a grouping strategy is possible. So we just group them up, factor them out, and then you get f of x is equal to x squared plus 2 multiplied by x plus 3, and we're done because this one can't factor. It's like fully factored. How do we know that one can't factor? Well, x squared plus 2 looks like this, right? It's just a quadratic that looks like that. It has no roots. I got no roots and I can't. Practice. Okay, I'm gonna pause the video and go ahead and work slowly away at the examples. Unpause the video and say goodbye. But you all can start practicing your own practice problems. If you want to do examples with me, join me. I don't know why I would pause the lesson. I'm just gonna work the examples. I'm gonna record me working on the examples. And if some of you drop F-bombs, that's your problem. That's you being posted on the YouTubes with your F-bombs. No F-bombs. Let's go. Y'all are good.
Now try this one. Comparison.
Are we still going on the lesson? Are you sure?
Now try out comparison.
After what you just said?
Okay, I do like this one. That goes right smooth after that. What?
I said he's for a second.
I'm very pretty. Try this one. Mr. J.
Yeah.
I have to leave at 2:10 today.
Mm-hmm. Okay.
2:10 is like a great time to leave. Because you're not missing anything, really.
No.
Is that a comment about my teaching?
I think it was.
No.
I
Yeah.
think it was.
Usually at that
You're
time
lucky
we're
I don't have
working
my
hard,
book
but you
that I
can-
write down mean things about
you
students
can,
in.
You can work hard at
So
home.
there's
on
a
the
chance I
questions
might-
given.
I might forget that you said that.
You're just talking over them now.
Yes, I've been worse.
Insulted. You talk over.
It's okay, you guys are matching. You guys are basically the same.
Yeah, no, we matched today for matching day.
Was that intentional?
Yes. I
Oh, you
texted
two are
him.
twinning.
This guy texted me, wear blue quarters of tomorrow. I went, awesome. I was like,
We need to tap our points for the leadership class.
Sorry, so you planned your outfit for the day before?
Right?
You planned your outfit the day before?
honestly, that's really not that absurd.
Every day I'm walking the first day when there's like a spirit day or something and someone looks at where's your spirit? I've started amping it up.
Nice.
It's not like some of us spirit days when she wasn't in the leadership class.
She is now, and I don't judge based on past. It's a new semester, new me.
It's actually
Oh.
actually ridiculous behavior.
It's ridiculous behavior from Connor.
New semester, new Connor?
Yeah.
Really, eh?
Diabolical.
It's sad, I've yet to see it. I've seen safe Connor. Not that there's anything wrong with that at all.
No, it sounds like there is, just the way you're saying
There's
it.
nothing wrong with it.
Same old Connor.
I love same old Connor. I'm less heavy with it.
Mm.
Well,
I said he was worse.
I did make you that one note.
It was like 10.
At the end, I almost.
You made him like 10 notes. It was an absurd number.
Did you ever consider doing just one more page with a little yes?
No, I can't say anything, no.
I was waiting for you
It
to.
was like, it was one note. I think
I don't think
Well,
so.
I don't
It
think
was
I
a
made,
few.
I don't think I made a note again after that.
No, you didn't. You took it personally.
I did, yeah.
Probably do the work, eh?
I thought you said you could-
Someone's got to do it.
I thought you said you could do it at home and there's nothing to do in class and it's the teacher's fault.
I said.
I think you
usually
should be
at two-
taking advantage of your time in school because
usually after 2:10,
I'm also here to help you out with your work.
Okay, what's the point of leaving at 2:10? Class is over at 2:15.
Yeah, why are you leaving at 2:10?
It's a secret.
Probably something to do with these apples, right?
The apples?
Yeah.
I'm never taking an apple from you guys if you put lemon on
You
it.
asked me if you
Because
could
when
put on
the
apples, and you
react-
said,
the reaction I had was so bad when I got home.
What reaction?
When the question is asked in a sentence form, give a sentence answer.
yes.
Generally. Yeah, it's just like good habit. And also like explaining what you're doing and all of those things. Like that came through in the lessons I did at home the other day, along with much, anyway, hilarity, so try that.
It's not like a bad reaction. Came pretty close.
Pretty well.
though.
I mean, beyond that, and it's a little bit like just how much torture can you stand? But you can still use these same techniques. Like, okay, I'm just going to test and see, oh, look, when I add up all the coefficients, it's 0. I can factor this sextic.
Do you have a favorite hockey team?
Do I have a favorite hockey team?
Yeah.
Team Canada.
For like
That's a
NHL.
great
but-
non-hockey.
For like NHL.
Scepters.
Senators?
Scepters.
The Scepters, the Sabres? Or?
No, the Scepters.
Oh, is
Toronto
that the-
Scepters.
yeah, the Toronto- my bad.
Yeah, I'm over the Leafs. The Leafs have broken my heart. I'm never watching them again until they're in the playoffs again, which apparently won't be this year. No, I'm a Leafs fan. I'm just joking. I am not a fair weather Leafs fan, but I'm not kind of into them right now.
What do you feel about Montreal, the Habs?
If they're doing well, I don't mind not hating them. There's no teams I hate. I'm not into cultivating hate in this inside this temple of love and goodness.
It's a generous way to like school.
No, I was referring to me.
Oh, okay. My apologies then. I like that response.
Yes? Are you kidding me? New notification sent Miss Carson. She says, let's do international. Is this interesting to you guys? Yes. But I
Where would you be going?
probably somewhere like France, Belgium, Luxembourg. It's Luxembourg.
You know what? Well, in French, but like it's the Luxembourg Royal Family. In French.
Yeah, thanks, Arden. That makes me feel a lot better, actually. That's perfect. That was a perfect comment.
Well, I had a speech and had everything about it.
You did the same thing, and I said Luxembourg instead of Luxembourg.
Because you made a point.
And
of
then
saying
you
it
said
like that.
French instead of France, and you're not gonna take it. Sometimes you just gotta take it, Connor.
I'm pretty good at taking things, aren't you?
Wow, Connor. That comes up in this little video.
Mr. Jennings, are you still recording?
Yeah, I turned it back on. I don't want to miss all this banter. The world needs this.
We're playing the checks tomorrow.
This is like going to be a slow burn of a comedy video, but I think this might be where I go viral. And I can, I can finally be free of all of you and quit my job and live off YouTube.
Is that funnier?
Maddie, you know I'm joking, right? Like if I'm talking and I'm not saying, and therefore the solution is, I'm probably joking.
What did you say?
You said, when you said you sometimes you just got to say, I said, yeah, you're pretty good taking things out of it.
I take things super well. At all times.
From all angles?
Specifically Connor's things.
Or you can go for a walk.
What?
Eric, when you join me on the walk.
Well, Connor, you're already leaving early today, so.
Where's my error? Was I wrong? Does f minus 1 not equal 0?
Connor, what are you doing after 210? Secret?
I interrupted myself to take a drink from my water.
The secret. Taking the secret.
I'm taking it. The secret. Is that what you call it?
No, it does. So where's my error?
Dude, this is low-key like a lot of steps, these questions.
There are a few steps, as you say. You are not wrong.
Oh man, I gotta list all the factors still.
Looked like it should work out. Minus, yeah. Okay, so I did 6x cubed, which makes absolute sense. Oh, there it is.
I think I listed them off.
That's plus. Oof. Oof. Yeah, it's like great because you get to find out, oh, you made your error way early and get to redo a lot of stuff.
Oh, that's right.
That was interesting that it just like flipped my remainder. Okay, so then we are minus x squared.
No, bro. What? Did you say something wrong with these numbers?
I would never.
Ugh.
Oh, that's an improvement.
Apologies.
You don't need that.
Pardon?
You don't need that.
My deepest apologies.
Ow, 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 ow.
Yep,
Can you come here?
You just poked me.
sure, right there.
Yeah, I'm poking myself up.
I genuinely think you should go for a walk now.
Because she's disturbing his
Mr.
learning.
Jennings, when I go to Washington.
Ooh, I got the answer.
That's fine.
Thanks.
Everyone's gonna say something, so.
Lifesaver. Jeez.
I apologize for that.
You know, I think that power from
No, you're rude.
Oh, whoa, jeez.
Say it.
Here I am preoccupied. I'm thinking I've got to go
It actually wasn't.
help Thomas out.
I didn't have anything yet.
Every time it goes for this one, you say pound doctor.
That's just what my dad calls it, so that's what it's brought up on.
You always kiss the fish.
That's weird.
You go.
Never mind. I don't like to kiss fish. That's not on YouTube.
It is.
It is?
Yeah.
When's this video going out?
When's it going out? I don't know. Let's see. Is
The
2 a
sooner the
factor?
better.
I'll have it up by this afternoon. It's 2 a factor, so that would be. I don't know, maybe 2. Positive 2. So we're 48 minus 4 is 44. Minus.
I think that is the
Yeah, 2. So we are positive 2 is also good.
Joey's told me so.
Where's it like the sign
Is that niche?
Okay.
Is that niche?
is? Of what?
Never mind. Don't worry about it.
This is
Have you ever cooked a fish?
Cotton cut? I feel like we have a few times back in the day.
You cut it. Did you cut it yourself?
No.
One place where you might make an error is like say here where I discover this one is 0 when x is 2. So then I go ahead and divide by x plus 2, but that would be incorrect. It has to be x minus 2. You know, you have to flip the sign there. So just watch out for that possible source of error.
on the topic.
French fries.
What a cute little small one.
French fries.
Is it a small mouth?
Oh, I don't know.
Right, chested pump. Would you pull that through?
Really finish the first question.
Sorry?
You mean like how many times did I drop it? It's like 10.
Yes.
Oh,
Yeah.
what? I felt really bad for him.
It's covered in dirt and fucking leaves.
I know, I don't.
Then you bring it back up. Oh, I see how you do it.
That is. That foot was the definition. It's all about the angle, isn't it? You shouldn't have included your thumb in the photo or your hand because then it shows the size of the fish.
Yes, sirskis. We have a test this Friday and this Monday. Well, next Monday. No, Monday.
Here, you want to see a really big accomplishment?
Oh, what are those called? I forget.
What about you have to kill them?
Yeah, I know these.
Yeah.
I was so I caught a beautiful fish. I caught a fish and then I fell in the water. So my dad.
Sorry, you fell in the water?
Yeah, it was on the dock.
Usually you let the fish do that.
Yeah, and then so my dad took a photo of me. Look at the way he holds fish.
Sorry, call 911.
Your dad. I didn't catch this one, but I did buy it.
Look at he holds fish constantly like this. Catch a pike and
He's like playing around with it.
these guys. I thought it was so funny to take this photo. Every time somebody in the family group chat, he doesn't want to eat, he puts that photo in.
That's a great thing to see. I love a good photo from time to time.
It's fair.
What do you do for
You love a good pizza from time to time?
It's a solid photo.
Oh, guess what? It equals 0.
See, look, every single fish.
Scripts make that there.
Okay, so those are the examples. They'll be in the video and I can leave them up on the screen for today. I'll pause on that one.
Catching a fish?
Thanks everyone.
That's the angle we want to take.
Bye for now.